All right, guys, it is time for some proof. So we got to write a proof here. We got to write a formal proof, which is really a kind of a very long process, as you guys have discovered. But in the end, don't be afraid of it. I mean, all you really have to do is explain how you got something using a certain starting point or certain starting value of information, which is what you got. So what we have to do, and let's identify that first. FMC, the angle FMC, we got to show to be 65 degrees. That's this guy, FMC. We got to show why that's 65 degrees. So if you want any hope of actually proving this or being able to prove this, the first thing you have to do is have a really solid plan. Um, so in other words, we have to justify in our own heads why in the world that would be 65. So let's do that first. Before we even write this proof, let's make sure that makes sense to us. It's 65 degrees. So this is almost like you're casually explaining to someone who doesn't really know what's going on, or just has to solve for a value. Like, how would you tell them that? Well, if I need to get this angle right here, this would be 65 degrees. Um, I know that I'm gonna need other angles to do that. Like, first of all, I can definitely see the congruency markings. So to get this guy, I'm probably gonna know this guy. But to know this guy and to know this guy would be enough because then I'd have a triangle. So to get FMC, I really have to know this angle MFC and this angle FCM. If I know these two angles, I am good to go. Um, Now, to get this angle, I have to go back and actually use maybe vertical to get this guy, um, which means to get this one, I really need this one first. So here's kind of what our plan is going to be. If I start with the angle 110 and use linear pairs to get this angle, and right now I'm just going to call it angle 1, but it came out weird, so let me erase it. Ooh. Okay, so here's how the plan is going to go. I'm going to start with this angle right here, this angle 110 degrees. I'm just going to call it something for right now. I'm just going to call it little a. So I'm going to start with angle little a, and I'm going to use linear pairs to get angle little b. By combining this angle little c and this angle little b, I can use triangle sum to get angle d. Vertical is going to get me angle e, and then combining the fact that I have a triangle again and the fact that these two are congruent, I will eventually get angle G. Now, notice I did something else. Like using the three letters to name an angle sometimes gets very confusing, especially when you're trying to explain to somebody. Remember, there's more than one way to name an angle. We could use it the three-letter convention. Like for instance, this angle at a 60, I could call it LJF. But also, I could just call it by a name directly, and that's what I actually did. This is perfectly legal to do in proofs. I can go through and actually change my diagram as I see fit. In this case, as I see fit is actually to name these angles. Now, you can't change any values, you can't change where everything is drawn, but I can certainly go through, and when I say what I see fit, what I really mean is you can change the names of things. So really, the way our proof is written now, I just have to prove angle G is 65 degrees. So once again, let's review our plan. We're going to start with A, use linear pair, supplementary, and all that to get angle B, and that should be 70 degrees. Using the fact that this is a triangle, and I know two of the angles, I will use that to determine angle D is going to be 50 degrees. From there, I'll get angle E to be 50 degrees because of vertical, and then using a combination of triangle sum and definition of congruency, because that's what these arc marks mean, I should be able to get M to be 65. So that's our proof, that's our plan, that's what we're going to do, so let's get into it. Um, Now here's a kind of a disclaimer before we begin. Uh, I am going to show you one way to do it, and I'm going to use one particular style to do it. In fact, I'm going to use a flow proof because that's really what my favorite kind of proof is. Um, there's many ways to write it. There's many ways to accomplish this task, and you'll find that's kind of a truism as you do more and more proofs. Now I had to erase it, so I'm going to go back. A, B, C, D, E, and F, and G. Okay, so let's just jump into it. The first thing you're probably going to have to try to establish is our givens. So that's what I'm going to write first. So our givens, not actually a lot, but this at least a few things in our diagram we need to determine. The first thing has to be this angle right here, which I have renamed C. The measurement of angle C is 60 degrees. I should also mention that the measurement of angle A is 110 degrees. And it seems to me angle G and F are congruent. So angle G is congruent to angle F. Now I don't know how much of that I'll use, but at least right now it's in my proof, and I can access it when needed. So now let's kind of take this in chapters. So this is my very first one. I said this is where I was going to start. I needed to get angle B to be 70 degrees. I was going to do that by linear pairs. Now, guys, if you haven't caught on, the deal with these proofs, especially when there's a picture, is that there's a very definite kind of order to follow. You always start with a structure because that exists and you know it exists because it's a diagram. From the structure, you'll pull some kind of relationship. And usually that's going to result in some kind of equation. I mean, the relationship is really kind of forcing you to have an equation. And from that equation, we can do some substitution and solving. So for each of these kind of chapters, that's kind of the route I'm going to take. I'm going to identify a structure first. From a structure, grab a relationship, and from relationship, now actually sub in values and solve it. So let me change colors here. So for this first set, this first one, I need B to be 70. So the structure in that case is going to be linear pairs. So the first thing I'd have to mention in my proof is that if I look at angle A and angle B, they're going to be supplementary. And the reason here is going to be because of the linear pair postulate, LPP. Now that didn't come from anything. Like that idea came from the structure, so no arrows in this case are necessary because nothing got me this idea except by simply looking at the picture. Hence, that's why we start with structure. Now from here, where we go? Well, again, now this is a relationship part, right? If we know they're supplementary, that's going to drive an equation for us. If they're supplementary, then the measurement of angle A plus the measurement of angle B has to be equal to 180 degrees. And that's going to be because of the definition of supplementary. Okay. Now there is some arrowing I have to do here because this idea came directly from the one above it, hence an arrow. So now I have the relationship. Now let's do the substitution solving part of this. In other words, let's replace these angles with angle values that I know. Um, so I do know angle A is 110 degrees. In fact, that comes from my givens. I'll probably have to draw an arrow there for that. Angle B I don't know, but you know what? I'm trying to find angle B. That's the next step in my proof. And of course, 180 stays 180. So I can definitely say this is because of substitution. Definition of substitution, but substitution nevertheless. Okay, so in terms of arrows, I definitely should draw one here because that idea came from there, but I should also draw one here from my givens because that's, again, I pulled the angle A 110 from that given statement. The final step of this is going to be to actually get a value. If I know angle B is plus angle 1 or plus 110 is 180, well, the measurement of angle B has to be 70 degrees. And I know that just because I'm actually solving. And I apologize, I'm writing over writing, but this proof actually got bigger than I thought, so I had to kind of adjust. And that idea comes directly from the one above us, so a single arrow will suffice here. Okay. So now I have the first part complete. I actually now know this is going to be 70 degrees. The next part was going to be combine that information and the triangle to determine D is 50 degrees. That's where we're going next. So it seems to me the structure is an actual triangle, but I don't have to mention I see a triangle because one is right here. I can actually jump right to the relationship. So I know that the measurement of angle B plus a measurement of angle D plus a measurement of angle C is 180 degrees, and that's going to be because of the triangle sum theorem. Okay? In other words, the relationship in this case is that there is a triangle, and those angles add to 180 degrees. Okay? Again, the idea came from nowhere except the diagram, so I don't need to do any kind of special noting there. But what happens next? Well, now I have a relationship, and let's do our substitute and solve step. Let's replace the values with the values we know. B we just determined is 70, so I'll write that as 70 degrees. Angle D we're trying to actually figure out. Oops. Eraser. Okay, so D we're trying to figure out, so we'll leave it at D. But the measurement of angle C, we do know that was actually part of our givens. That's going to be 60 degrees. Okay? That's going to be 180 degrees as a total. So what we did here was substitute. So I'll go ahead and write because of substitution. In fact, I'm just going to abbreviate it. So now let's be careful with actually the connection of our ideas. Certainly here, because we modified the equation, but I also think we grab 70 from here, and we grab the 60 from here. So the idea is actually a conglomeration of three ideas. Okay. Now from here, we just need to actually get our value. So the measurement of angle D should be 50 degrees, because 70 plus 60 is 130, plus 50 more is 180, and that's just because of solving. Okay. So as we're being careful in connecting our ideas, it comes just from the one above it. Again, just finishing off that equation. Okay. All right, so now we know that this guy is 50. And different color, let's go green. We know this angle is 50. Now we have to determine this one is 50. And it seems to me, again, structure-wise, it's going to be because of vertical angles. But then we have to think about relationship substitution solving. But the very first step is determined for us. We have this angle being, I'm sorry, we have two vertical angles. So the structure in this case is that angle D is congruent to angle E. And that's going to be because of the vertical angle theorem. Again, structure is going to be vertical angles. The idea comes from the diagram, so no connection needed. But if I know that there are congruent, then by definition of what it means to be congruent, angle D has to be equal to the measurement of angle E. And I can quote directly the definition of congruency. Now, this idea did come from somewhere else. This came directly from this guy, so one arrow is appropriate. So now that we know the measures are the same, and I know that angle D is 50, I can conclude that the measurement of angle E is also 50. Okay? And we can call this substitution. Okay? So definitely the idea came from here because we modified it. But I would also argue the idea came from here because we solved for 50 in the previous step. So now we're almost done. Okay? We now need to kind of determine this last step. Now we know this guy's 50, how to get this guy to be 65. But I do have to apologize. I'm going to have to kind of pause the video right here because I need to create some more space. So I will be right back. Okay, sorry about that. And I just kind of didn't plan out my space very well. So now we have that this angle is 50 degrees, this angle is 50 degrees. We have to finish this up. So this is angle G, this is angle F. Now, the one given we haven't used yet is that these angles are congruent. That's what we have to do now in conjunction with the fact this is a triangle. So this word's going to get a little complicated. So here's where I apologize. I'm going to be scrolling up and down, but that's just kind of how it has to be. So again, kind of using our guide right here, structure, relationship, sub, and solve, we have to think about the structure of the triangle, and that's actually where I'll start. So let's establish the triangle sum theorem first. So let's change. Let's write blue. So the measurement of angle E plus a measurement of angle F plus a measurement of angle G equals 180 degrees. Now again, that comes from the idea that this guy is a triangle, and if I add those three angles together, I should get 180 degrees because of the triangle sum theorem. Okay. Again, the idea came from the diagram. No additional kind of arrowing needed. We can do a substitution here, but that's not going to get us very far right now because all I can replace is angle E. Then I have these guys right here. I don't know if I'm ready to do that yet. So let's put a little pause on this chapter, and let's go back and explore our givens a little more because I think that's actually where we're actually going to get the most traction here. So the one fact that we haven't used is that angle G is congruent to angle F. But if they're congruent, just like over here, congruency gives us an equal measurement. I think that's something we should mention. So let's actually take this idea from the given, and let's move it down here. Okay? And if they are congruent, that means the measurement of angle F has to be equal to the measurement of angle G. And that's just directly from the definition. Ooh, because the definition of congruency. Okay? Now that's an odd one to kind of stick out to the side here, but I think it's going to be really necessary before we start the substitution. So before we do that, let me just quickly review. From our given statements, this one in particular, okay, if those angles are congruent, then by definition of what it means to be congruent, their measurements are the same. Okay? So let's jump over back to the blue chapter. Okay? I have the three angles in this triangle, boom, 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 adding together to make 180 degrees. That's fantastic. But I need to solve just for angle G. This is what I want to actually care about, which means I have to kind of change these ones to something that is more usable. Now, I do have some substitutions. I just found angle E is 50 degrees, so I can rewrite this equation. Instead of measuring angle E, I can just write it as 50 degrees. Now, angle F, I don't know a definition of, but wait, look over here. Angle F is the same as angle G. I'm trying to solve for G, so I can rewrite this as a measurement of angle G. No, I still got this one, but I think I've created myself a solvable equation. What I really have here now is just one unknown, although it does appear twice. So let me explain further what I mean, but let me get substitution down here first. Okay. So we modified the equation here. We borrowed the 50 from this guy, and we borrowed the angle F equal to angle G from this guy. Okay. Uh, so how can I actually deal with this? Well, think algebraically. If I have like an x and another x, that's two x's. So if I have angle G and another angle G, that's two angle G's. So let's move this 50 to this side. So what I'll really have here is 2 times the measurement of angle G is equal to 130 degrees. Okay? Uh, if I divide both sides by 2, that leaves me with the measurement of angle G equaling 65 degrees. Well, that's what I was trying to prove in the first place. So all I really did here, again, is a solving step. Solving, in particular, this equation that I was given. But in the end, I now have shown exactly what I was trying to prove in the first place. Measurement angle G equals 65. So I would call this a good proof. Okay? All the steps are accounted for. Uh, no holes, nowhere to attack. Messy, yes. Long, definitely. But again, just go back to just use this kind of structure relationship sub and solve as a guideline for these, and then break it into pieces. Go to your plan. Find 70 first. That's what we did here. Use triangle sum to find 50. That's what we did in the second step. Use verticals to flip 50 to the bottom triangle. That's what we did in the green step. And then use triangles combined with the definition of congruency to determine what angle G is. Okay? So as a whole proof, again, long, messy, arduous, but one that you guys can certainly do. So again, hope this helped. Review it, rewind it, watch it again. This is all stuff that will be good to do in reviewing for your quiz tomorrow.